Okay. So once again, the first thing that we're going to do is we're going to solve for the complementary solution through the auxiliary equation. All right? So the auxiliary equation would be m squared plus 1, which equals 0, or the m squared equals -1. So m equals plus or minus I. So our complementary solution, y sub c, is going to be c1 Now, y sub p is of the form it's a quadratic, so it's going to be quadratic. Okay. All right. That means that y now prime is 2ax plus b, and y prime prime is just n equal to it. So let's take those quantities and we're going to plug them back into the differential equation that we were dealing with at the beginning. So y prime prime plus y is supposed to equal x squared plus 1. So this means that 2a plus, and now let's plug in this a right here, ax squared plus bx plus c is supposed to equal x squared plus 1. Okay. All right, so if I group everybody together, this is going to be, I'm going to write it like this: ax squared plus bx plus 2a plus c equals x squared plus 1. Okay. Now, this is going to lead to 3 equations. All right? The first equation is just coming from the quadratic term that a equals 1. Now, there is no x term on the right-hand side, so that actually does lead us to another equation. That leads us to b, which equals 0, because there is no x to push. Right? And then we have this last one, with 2a plus c is supposed to equal 1. Okay. But we already know that a is 1 from over here. So, all right, so this thing right here shows 2. So that's 2 plus c equals 1. If you subtract 2 from both sides of the problem, you're going to get that c equals -1. Okay. Okay. So the y that we're looking for is y, which equals c1 cosine of x plus c2 sine of x, and then plus x squared minus 1. So now we're going to use our initial conditions. So y, well actually these are boundary conditions on this one because they're both not initial. So the first one's an initial condition. Yeah, y of 0 equals 5. And y of 1 equals 0. So guys, you can't have conditions at other points besides just the initial conditions. A perfect example of this is when we were dealing with models before. Remember, if you're doing Newton's law of cooling, you have an initial temperature of whatever metal bar or whatever you have. And then let's say you threw it outside, you had to go check on it a minute later. That would be a minute into the future. So you would consider this one at just another point further in time if we're calling it x time. Okay. So y of 0 is going to equal 5. So 5, okay, so cosine of 0 is just 0. I mean 1. So that's C1. Sine of 0 is 0. Okay. All right. This term and that term are going to disappear because they're zeros. And so we end up with 5 equals C1 minus 1. And so if we add 1 to both sides of the problem, it's going to cancel that out. And we're going to get that C1 is supposed to equal 6. Okay. All right, the next one's going to be a little bit trickier. So y of 1 is going to equal 0. Okay. So what are we getting? 0 is going to equal, well, we already know what C1 is. C1 is 6. And so that would be a cosine of 1 plus C2 sine of 1, okay? Plus now 1 squared minus 1. Okay. The 1 squared and the minus 1, those guys are just going to cancel each other out. So the one we have to consider is just C2. So we can say, all right. Okay, not the prettiest answer, but it is an answer. So, what is the actual solution to the rest of the problem? Y is going to equal 6, now cosine of x, minus 6 cotangent of 1 times sine of x, and then plus x squared minus 1. Okay. And that is the solution that we were looking for.